Hello, good evening. It's Friday evening, and what better time to go over the formative assessment from Economic Principles and Policy. And without further ado, I'll get right into it. Question 1. A firm whose production function displays increasing returns to scale will have a total cost curve that is, and then we're given a number of choices. So increasing returns to scale. That means that I can double production with less than double the inputs. Okay? And if I can double production with less than double the inputs, the input cost is staying the same. Double the inputs would cost me twice the cost. But if I can double production with less than twice the inputs, I can double production at less than twice the cost. Okay, so for instance, if I have output is a function of capital and labor, if it has increasing returns to scale, that means that if I multiply capital and labor by some amount alpha greater than 1, I know that the output I'll get, f of alpha k, alpha L, will actually be greater than alpha times the original amount, or the alpha times the amount with the original level of inputs. Okay, so if this is 2, I can double capital and labor and get more than double the output. One example would be, and you can try it, is what if f of capital and labor was equal to just simply the product of capital and labor? Well, if I have capital at 1, labor at 1, then I'll get quantity k times L, 1 times 1 equals to 1. My total cost will equal price of capital times the price of labor. My average cost will equal this divided by 1. Okay? Okay, now, by the way, and I haven't emphasized this, but firms that are optimizing, when they choose positive amounts of both of these inputs, and they have this diminishing marginal rates of transformation, or I always forget what it's called, diminishing, so this is all the amounts that produce, this is all the combinations of capital and labor that produce the same amount. They will set the rate at which they can trade off capital for labor to produce the same amount equal to the price ratio. Okay, so suppose that the price of capital was equal to the price of labor, or we say the rent and the wage, and suppose that both were equal to 1. Well, I'm going to set, this is again, it's very similar to the consumer case. They're going to, if they want to produce for whatever amount of output they want to produce, they're going to set the marginal product of capital over the marginal product of labor equal to the price of capital over the price of labor. So that the slope, they're going to find the point in producing this amount such that the slope of the trade-off in the production function equals the slope that they can buy and sell each. Could also rearrange this, MPK over PK equals MPL over PL, bang for the buck. Condition equal. So if price of capital equals price of labor equals 1, well then, what is the marginal product of capital if I have this function, f of KL equals K times L? Well, if we remember our rules from calculus, the derivative of this with respect to K is equal to L, and the derivative of this with respect to L is equal to K. We treat the other argument as a constant. So, marginal product of capital is L, marginal product of L is K. I'm not going to ask you to remember that, although it's a nice thing to know. The derivative of this function with respect to L and with respect to K. So L over K equals PK over PL. If we say they're both equal to 1, PK and PL are both equal to 1, 1 over 1, L over K equals 1. In other words, L equal to K. So if prices are equal, and this is their production function, they'll set equal amounts of capital and labor as I tried out here. Okay, those will be the ones that will be the cost minimizers. Okay, you don't have to know that, but I thought it might be good for having some context. Okay, so, but now suppose they decided to produce twice, or suppose they want to produce 2. Well, then they need capital times labor equals 2. But we know they're going to set equal amounts of each, so we could substitute K for L. So K times K, or K squared, equals to 2. K would equal square root of 2, which is something around 1.4. And similarly, as I said, if K is going to equal L, L will also equal approximately 1.4. Okay, so I could double output, because this is the one case where we have increasing returns to scale. I can double output by simply setting less than doubling the inputs. So I set K equals square root of 2, L equals square root of 2. And now quantity equals root 2 times root 2 equals 2. Okay, let's go with this pricing equals to 1. Okay, so total cost, 1 unit of capital, 1 unit of labor, each priced at 1. So 1 plus 1 is 2. Average cost, 1 divided by 2. Sorry, average cost is total cost divided by quantity. Right, average cost equals total cost divided by quantity. Or total cost is average cost multiplied by quantity. It should be fairly intuitive. Okay. Total cost is 2. Average cost is 2 divided by 1 equals to 2. Here, total cost is the price of capital times root 2 plus the price of labor times root 2. Well, those are both price. We're saying PL equals PK. By the way, we often call this wage and this rent, equals to 1. So they're going to spend root 2 on capital, root 2 on labor. They're going to spend total of 2 root 2. So the average cost will be 2 root 2 divided by 2, or just root 2. Okay, so we were able to double. When we double the output, we reduce the average cost. We less than doubled the cost. Okay, what does that look like? Let's get back to the question. What does that look like in a cost function? Okay, well, imagine we're talking about our total cost function. I think that's what this is. Total cost curve. Okay, so now we think, if the firm wants to expand its quantity, how much will it cost? Well, if the first answer is a straight line through the origin, well, if it's a straight line through the origin, then doubling its quantity must double its cost, going from 1 to 2, right? That's what these straight lines mean. And with whatever the slope, every time you double it, you'll double the cost. Okay, every time you increase it by some share, you increase it by the slope times that share. So A cannot be our correct answer. B, a curve with a positive and continuously decreasing slope. Okay, so in other words, something like this. All right, so here, let's see if this fits the bill. First of all, does total cost increase in quantity? Of course it does. You need more inputs to produce more outputs. We see that in a function like this. I would need to increase capital and or labor to get more output. Okay, so increasing, yes. What about the slope? Well, it says, is the slope constantly decreasing like in here? Well, this would seem to get us what we wanted. So the slope tells me what is the rate at which I must increase costs to get more output. And if I have increasing returns to scale, I can get more output when I can get more output at lower and lower costs for additional units of output. Because I have to, if I have increasing returns to scale, the more I produce, the less inputs I have to use per unit. Okay, I have to less than double my inputs. So for instance, if I go from 1 to 2, in this case, I go from a total cost of 2, let's say this is 2, to a total, let's say 1, 2, total cost of 2, to a total cost of over here, 2 root 2, which is less than 4, okay? It's going to be about, if root 2 is about 1.4, 2 root 2 is going to be about something around maybe 2.8, if I'm remembering root 2 correctly. Okay? That's question 1. So B is the correct answer. Now you should check C and D. Okay, what if it was a curve with a positive and continuously increasing slope? Well, the positive is correct, but that would mean if it had a continuously increasing slope, okay, let's have it, just to make it simpler, let's have it start from 0. Total cost of quantity. That would mean if I wanted to double my quantity, I would have to more than double my cost. Okay, let's go from 2 to 3 to 4. All right, so you see here, if it had an increasing slope, if I go to 2 to 4, I seem to have to more than double my costs, right? Because everywhere it's getting more and more expensive to produce additional units. So C is an incorrect answer, and D says a negative slope. You'll never have a negative cost curve, okay? It always costs more to make more. That's kind of obvious. All right, moving on to question 2. Which of the following are correct? Choose 2. Now, remember I said on the midterm, there might be questions that say you must choose 2. And on many of those questions, this one like this, presumably, I will say you can gain partial credit for each answer. Let me just check we're still recording. And we are. Okay, question 2. If average costs increases in quantity, the marginal cost, which of the following statements are correct? So it's just a bunch of statements. If average cost, AC, increases in quantity, the marginal cost must be above the average cost curve for each level of output. All right, let's draw that and see if it seems to make sense. Okay, so average cost increases in quantity. And we're saying the marginal cost curve is above the average cost curve for each level of output. Okay, so we have 1 unit costs us some amount, costs us, let's say 1. 2 units, well the first unit cost 1, average of 1 per unit. All right, so what's going to get average cost to increase in quantity? Decreasing returns to scale, by the way. Well, the second unit, for the average cost to increase, must cost more than the first unit. So the marginal cost, I'm doing this stepwise rather than continuously, just for the illustration. So the first one cost us 1, the second one, maybe it costs us, 2. So the marginal cost of that second unit, of the first unit, was 1. The marginal cost of the second unit was 2. Sorry, this is confusing. This point is 3. The second unit cost us 2 more. So here I'm mapping the total cost. But if I'm mapping the marginal cost, first unit cost me 1, second unit cost me 2. Okay, let's go with this. Let's say the third unit costs me 3. So this is actually the margin. Suppose I'm looking at the marginal cost here, okay? Suppose this is my marginal cost of Q. Every unit that I'm producing is getting more and more expensive to produce than the last unit. Okay? So is average cost, now let's look at the average, the total cost and the average cost, okay? So the first unit costs me 1. So to produce 1 unit is 1, second unit costs me 2. So to produce 2 units is 1 plus 2, or 3. The third unit costs me 3. So to produce 3 units is 1 plus 2 plus 3, 3, 4, 5, or 6. So the total cost is going way up in this case, okay? This will be our total cost of Q. What about the average cost? And by the way, they didn't ask about the average cost. Okay, what about the average cost? This is the marginal cost of Q. Well, the first unit costs 1. So the average, so let's say Q, cost, and average cost. So to produce 1 unit, cost 1. To produce, so we have 1 divided by 1 equals 1. Second unit costs 2. So if I want to produce 2 units, I have to pay for the first and the second unit. So the total cost here was 3. Average cost is 3 divided by 2, or if you would like decimals, 1.5. Third unit cost me 3, so that I had to pay 3, 4, 5, that got me all the way up to 6. Average cost 6 divided by 3 is 2, ... Okay, if average cost increases in quantity, all right, so let's draw the average cost here. So we have average cost increasing in quantity. The marginal cost must be above the average cost curve for each unit of output. Okay, this was for stepwise, but basically this is correct if we allow for these fractional units of output. Okay, so the average cost curve will be increasing something like this. Okay, and why is that? Because the first unit costs this amount, this amount, right? And so basically at the zero it starts the same. So the first microscopic unit, it's the same, but everywhere else, the first unit costs this amount, but the less than first units were less than that are easier to think about. The second unit costs this amount to produce, but to look at the average cost, we need to look at the average of the first and second unit, so it would have been about 1.5, right? The additional unit always costs more than the previous unit. So if I take the average of all the units, it's always going to be above at every quantity, it's the average. If I take the average of all the previous units, it's always going to be, below than the cost of that next unit. Okay, long answer, A is correct. Now I gotta find what else is correct. All right, some weird things here. Economists include the opportunity cost of capital in their definition of revenues. Well, this could be throwing you for a curveball, because we do include the opportunity cost of capital in our definition of profits, but not revenues, right? Revenue is essentially just equal to price times quantity. So there's no opportunity cost of capital in there. B, C, total costs are the sum of marginal costs and average costs. That doesn't even have a meaning. Add marginal cost to average cost, what is that? Think about it, that makes no sense, no. Total cost could be average cost times quantity. Total costs will be something expressing variable costs and fixed costs. There's different ways of writing it, but it's not marginal cost plus average cost. That's just wrong. C, and D, the marginal cost intersects the average cost curve at its minimum. Well, actually, in this case, that's a bit undefined, okay? But, so perhaps I should have said, but this is not the usual case we're giving you, okay? So, when in doubt, think about the usual case I'm giving you. Otherwise, I would have put some very careful caveat here. I'm just looking for my board eraser. Is it hiding? Yes. Okay, so the typical case that we're thinking about, or many of the cases we've thought about, we have perhaps diminishing marginal cost at first and then increasing, or we have some fixed cost which makes average cost start above marginal cost. But let's look at the case that I've shown you before. So marginal costs start up here, and then they decline and then increase. Okay, so let's make this marginal cost equals to quantity. Okay, so average cost is going to the first unit start here. Okay, but we don't mean that when we say intersect. Okay, if there's no fixed cost. If there are fixed costs, actually the first unit, the average cost may start above marginal cost, I believe. But let's do it like this, okay? So first unit this much, second unit costs this much, but averaging the two, I'm somewhere between those two, okay? Third unit, average the previous ones, etc., etc., etc. Okay, but then why is it that this is average cost of Q? Intuitively, why is it that at the minimum of the average cost function, a very important point, this is min average cost. This is a very important level, as we recall from our discussion of perfect competition and equilibrium. Why does it intersect the average cost curve at its, in other words, the average cost curve's minimum? I'll highlight this in green just to be clear which one is which. All right, average cost is highlighted in green, okay? Well, before this point, marginal cost was below average cost. Right? We were having decreasing marginal cost, and all of these marginal costs were below the average cost, so we're bringing down the cost. Just like when you get a mark below your previous average, you're dragging down your average. After this point, marginal cost jumps above average cost. So additional units will cost more than the average of the previous unit, so they start dragging the average up. Just like once you start scoring marks on quizzes and exams above your previous average, you're dragging up your average. Okay, so what did we get so far? We had A was correct, check. B didn't make much sense, no. C, the marginal cost curve intersects the average cost curve and it's the average cost curves, in other words, minimum, check. All right, now I got 2, so I don't have to keep fishing, but I might as well, because then in case I find another one that looks correct, I can double check whether I got this wrong. Okay, D, the marginal cost curve, sorry, C was incorrect, I apologize. D was the one we just talked about, the minimum. Finally, there's good old E. If marginal costs decline as quantity increases, but there are large fixed costs, this implies constant returns to scale. Okay, that is not going to apply constant returns to scale, okay? Constant returns to scale are going to require no fixed costs, okay, and a constant marginal cost. It has to be that when I double quantity, I double cost. The only way of doing that is if there's no fixed cost to producing that first unit that gets averaged overall. So constant returns to scale, that is going to imply constant average costs. Okay, and also it's going to have 0 fixed costs and constant marginal cost. Okay. Otherwise, I mean, you can look at the average cost if we want to talk about fixed cost and marginal cost. So average cost is equal to, well, total cost is equal to fixed cost plus marginal cost. Okay. So average cost is equal to fixed costs divided by Q. Total cost is not equal to fixed cost plus marginal cost. Total cost is equal to fixed cost plus variable cost, which I haven't discussed much, but that's the sum of the marginal costs, okay? So average cost is equal to fixed cost divided by Q plus variable cost divided by Q. Okay, so if I want average costs to stay the same, I have to have zero. If I had a positive level of fixed costs, we'd see average cost declining as Q increased, at least holding everything else constant, okay? So basically, all right, there's one exception, but forget about the exception. Basically, to have average costs constant, I have to have 0 fixed cost and a constant marginal cost. If I have a constant marginal cost, my total cost, and 0 fixed cost, my total cost is equal to 0 plus whatever that marginal cost is, let's just call it a constant C, times my quantity, so my average cost would just equal CQ over Q, or just simply that constant Q. So it will be a linear function with slope Q. Okay. It would not be a case with fixed costs, large fixed cost, and diminishing marginal cost, okay? Or at least it wouldn't be that in general. That statement is incorrect, okay? But I don't want to go into detail on that, okay? So let's move on. Just checking we're still on. Yeah. Okay. Question 3. For a constant returns to scale production function. Okay, more of this constant scale returns to scale. Select one. Marginal costs are constant, but the average cost curve has a U shape. Okay. Well, part of that statement is correct. Marginal cost constant marginal cost would lead to constant returns to scale, but that wouldn't have a U-shaped average cost, right? Sorry, I'm not supposed to say right. Okay, so if I have constant marginal returns to scale and suppose no fixed costs, by the way, the fixed costs I'm talking about, let's call these avoidable fixed costs, okay? Costs such that if I produce anything, even an epsilon above 0, I attain these fixed, all of a sudden have these fixed costs. But if I were to actually go to 0, I don't have to worry about these fixed costs, okay? So we're not talking about these costs you pay each year at the beginning of the year to keep the factory in existence, which are sunk costs from the point of view of the middle of the year. I'm going to ignore those. I'm going to ignore that kind of fixed cost, that kind of sunk fixed costs or unavoidable fixed costs. I forget the term. Okay, let's forget about that. Okay, constant returns to scale production function. Marginal cost curves are constant, but the average cost curve has a U shape. Well, if marginal costs were constant, let's assume no fixed costs, so we start at 0. No, that doesn't mean we start at 0. My apologies. So the first unit costs me, well, it depends if I'm talking about total cost or marginal cost. If I'm talking about total cost, we should start at 0 with no fixed cost. If I'm talking about marginal cost, the first unit does cost something to produce, okay? So, relative to 0, compared to 0 units, okay? So marginal costs are constant, but the average cost curve has a U shape. Well, if marginal costs, that's not marginal cost. If marginal costs are constant marginal cost, suppose marginal costs are constant at 2 per unit. Okay, marginal cost of Q. Okay, well, if I produce 1 unit, it costs me 1 times 1. If I produce 2 units, it costs me, 1 times 2, or 2. If I produce, the first unit costs me 2 to produce. The second unit costs also 2 to produce, because the marginal cost of the second unit is also 2. Okay, so the average costs would, the marginal cost would be constant. Every unit costs me 2 to produce. What's the average cost going to be? Well, so total costs equals, if the marginal cost is the same for every unit and there's no fixed cost, and suppose it's 2 times Q, average cost will equal 2 times Q divided by Q equals to 2, obviously. So here it will equal the average costs. It won't be, as this answer claims, U-shaped. Okay, so A is wrong. B, both average and marginal costs are constant. Well, that's looking like the right answer. Okay, if average and marginal costs are constant, if I want to produce 1 unit, it costs me 2. 2 units, 4. 3 units, it'll cost me 6. Right? So total cost is 2 times Q, for instance, or something times Q. So average costs stay the same. Tick. So it looks like B is the right answer. So we don't have to keep looking, but let's do. Marginal cost has a U shape. Average costs are constant. If marginal cost had a U shape, it would be strange. I don't understand how average cost could possibly be constant. In general, at least, that won't be the case, okay? Because you'll think if we're forgetting about fixed costs at least, the first unit cost me this amount, the second unit cost me slightly less, let's say, so the average of the two is here. That's not looking like a constant average costs. Okay, so C, let's X that out. And D, both average and marginal cost curves are U-shaped. Well, that's what I drew here, but if the average cost curve is U-shaped, that's not constant returns to scale. Constant returns to scale says if I double output, I double the number of inputs I have to use, therefore inputs prices stay the same. I double my cost, so twice the cost, twice the output, average costs stay the same. So D is clearly correct. Question 5. All right, we're moving on from costs to, at least in this question, to the decisions of a firm. If the demand faced by the firm is inelastic at a particular point, selling one at the relevant point, the point we're talking about, selling one more unit of output will do what? Will it increase revenues, decrease revenues, keep revenues constant, increase profits, or allow the firm to increase the price? Okay, so the demand faced by the firm is inelastic. Okay, what's this demand curve looking like? Okay, price, quantity. Okay, remember, what's elasticity? Elasticity is percentage change in quantity for divided by the percentage change in price. Or actually it's the negative of that, or the absolute value of that. Okay, we call that the price elasticity. Or you could also say it's the change in quantity over the original quantity divided by the change in price over the original price. But we're particularly thinking about this as these changes become very, very small. Okay. What does it mean for the demand to be inelastic? Okay, elasticity. So suppose we say, suppose it's inelastic. Okay, it means it's less than 1. All right, it means that as price increases by a certain share of the original price, quantity increases by a lower share of the original quantity. Okay, so in a certain sense, quantity increases by proportionally more than price does. Okay, so this increases, all right, did I say more? I meant less. By less than price does. Price increases by more than quantity as a proportion. Okay, so this term is smaller than this term. Okay, so we have this being less than 1 in magnitude. So the absolute value of it is less than 1. So let's say less than 1. Okay, what was the question again? Okay, so what if I want to sell 1 more unit of output? So this is talking about how does quantity change as I increase price. But equivalently, we can talk about how does price have to change if I want to increase quantity. So if percentage change in quantity is less than the percentage change in price, if I want to increase quantity by a certain amount, I have to raise price by a greater, or a certain proportional amount. I have to raise price by a greater proportional amount, which means that my total revenue, which equals price times quantity, proportionally, this has to fall more than this. So total revenue will decrease. By the way, this only holds at the very margin. I put a post about it if you're interested on the extra stuff forum announcement thing. It's not the announcement, it's the extra stuff. Okay, so this only holds just at the margin, at least. Okay, but anyways, sell 1 more unit of output. If I want to do that, I will have to increase price by a greater proportion, which will cause my revenue to fall. So A, increase revenues, is not correct. B, decrease revenues. Well, we just said, yes, it will decrease revenue. So B would seem to be the correct answer. But let's just look at the other ones. Okay. This is more or less, I spelled this out in the. All right. By the way, what will this demand curve look like? Well, presumably it'll be downward sloping. Right. Inelastic doesn't necessarily mean perfectly inelastic. Perfectly inelastic would be such that the price that they'd be willing to consume the same quantity at any price. Okay, so but we didn't say perfectly inelastic. And actually, as I said before, the downward sloping demand curve actually has different elasticities. A linear downward sloping demand curve actually has different elasticities everywhere. That's why I said at the relevant point. Okay, so if I'm at a point like this, where in fact it's inelastic, so if I want to sell 1 more unit of output, I have to price. So price is is already rather low. I want to sell one more unit of output. I have to raise, and quantity is rather high. So the change from here to here as a proportion of this amount is less than the change from, so the change from, suppose this is 1 unit, from here to here as a proportion of this amount, right? Here, this looks like nearly half of it, whereas this is only a small share of the quantity. So as I move from here to here, the rectangle of total revenue will indeed get smaller. Okay? Probably not, in fact, it definitely, moving in this direction would not be a good idea. Okay? But also, something that I guess I ask you in a different question, we also know that if I'm at this point, if I'm at an inelastic point, if I'm a firm facing inelastic demand, I'm actually not choosing an optimal price and quantity. Okay? I can make myself better off by moving in the other direction, but I haven't asked you that here. Okay, so A was correct, B was incorrect. C, keep revenues constant. No, this is mutually exclusive to B. You can't both increase them and keep them, decrease them and keep them constant. To B. D, increase profits. Well, if I were to increase quantity, I've decreased revenue. What is profit? We usually use pi. Profit is equal to total revenue minus total costs. Okay, total costs and total, well, these will both be functions of, this will be a function of quantity and price, this just of quantity. Well, if I increase quantity, right, we've already decided that total revenue has gone down. If I increase quantity, what happens to total cost? Well, think about the total cost curve. It's always upward sloping. So this guy goes up. So, well, the negative of it, so in other words, the thing that we're subtracting goes up. So, therefore, this adds to, this subtracts from my profit, and this gets larger, so if I put a negative sign in front of it, it's also subtracting from my profit. So profit most certainly does not go up. Finally, does it allow the firm to increase the price? No, of course not. That's at least not in any normal case, okay? That would be really weird. So if you want to sell more, you have to reduce the price. Okay, so not all right, we're still going strong. We're still going, if not necessarily strong. What about a firm that decided, question 6, to maximize a revenue rather than profit? What level, essentially, which the question says, a firm that decided to maximize revenue rather than profit, maybe for some reason it wants to maximize market share in the short run, or revenue in the short run for some long run gains, maybe they're just power mad, it would choose to produce an output level for which marginal revenue was equal to what? Okay, well, I haven't yet brought in marginal revenue, but marginal revenue is the rate at which revenue increases in quantity. Okay, it's the rate taking into account that at least for a firm who's a price setter and not a price taker, you're facing a downward sloping demand curve. So if the firm wants to increase quantity, as we just said, it has to decrease price. So in other words, the question is, so what's revenue? It's price times quantity. It's this rectangle. Okay, that's not profit, that's revenue. Okay, what is marginal revenue? It says, well, if I increase quantity a little bit, knowing that I will have to also decrease price by that amount, how much, this will be my new rectangle, how much does this area change? Okay, and I'm not going to show you the calculus of that, I'll just give you the intuition for it. Okay, so in other words, we lost a certain area by reducing price, this area here, but we gained a certain area by increasing the quantity, this area here. And the question, the marginal revenue tells me at what rate am I increasing or perhaps decreasing revenue, okay? So, if this is the demand curve, or I like to call it the quantity demand as a function of price, there's also, I can also plot the marginal revenue curve, okay? For a linear demand curve, actually, the marginal revenue curve will actually look like a line with twice the slope. So this will be the marginal revenue curve. And let me try to give you some insight for that rather than giving you the calculus, which you can look up in the text, I believe. So the first unit, I am selling, kind of to one person. So I'm just getting the price for that first unit, and I'm not having to reduce the price of any previous units. Okay? The second unit, I'm getting a lower price if I choose to produce 2 instead of 1. I have to put a lower price for all of my units. Okay, so even though I got this amount, whatever it was, 10 for the first unit and 9 for the second unit, let's say. Sorry, I get 10 if I only sell 1 unit, and I get 9 for each unit if I sell 2 units. So I'm getting 9 for the second unit, yes, but the marginal revenue for that second unit is less than 9. Right, here's the marginal revenue, because in order to sell that second unit, I had to reduce the price on both. I had to reduce the price essentially on the first unit. Okay, so there's still a marginal revenue. I'm still increasing the area of this rectangle, it looks like, but not by quite as much as the price of the second unit because of this sort of loss here. Okay, so the marginal revenue will trail and actually have, as I said, have half or twice the slope, if you like, of so this is marginal revenue, just to remind you, MR with Q, of the demand curve, which I'll call quantity demand function. Okay, and I gave you the example in the lecture where you increased, you sold 1 more, but you had to decrease price by 1p. Okay, so that's why the marginal revenue is everywhere below the price. Now, look at this. The marginal revenue can become negative. At a certain point, think about this line, right? So the question of how much revenue do I gain is the question of, at a particular point, what is the area of this rectangle, okay? And for example, I believe if the slope is -1, the point that makes this rectangle the biggest would be the point where it's actually a square. Okay? So then, here, the revenue rectangle is the largest. At this quantity, which is not necessarily, unless the costs are 0, it won't be the optimal quantity, but it would be the revenue maximizing quantity. So it's some funny quantity, whatever you want to call it, quantity R max. Right? So if I look at this point, here's the price I'm getting for that I have to set if I want to sell this many units. The revenue I get is this rectangle here. It's actually a square if this is slope -1. But if I were to then try to increase quantity beyond that, all of a sudden the rectangles start getting smaller in area. What that means is that the marginal revenue, which is, again, this line here, after this point starts becoming negative. Okay, so I want to produce, if I were, for whatever reason, and this is not what firms usually do, they're usually going to set marginal revenue equals to marginal cost. If I were trying to maximize the amount of my revenue, I would then produce an output so that the last unit I produced, which I sold at this price, if I were to produce any more, the previous unit, my revenue is still increasing. If I were to produce any more, my revenue starts decreasing. So at this point, my marginal revenue is precisely 0. Okay, so for firm that sought to maximize revenue would choose to produce an output such that marginal revenue was equal to what? Okay, let's look. A, marginal cost. Well, no, that would be the revenue. That would be, so if I choose where marginal revenue equals marginal cost, you see, past this point, revenues are still increasing. It's still increasing. Past this quantity here, marginal revenue here, price here, past this quantity, I'm still making this rectangle bigger. Okay, now, it turns out that, well, as we've argued before, this is the quantity that will maximize profit, but it's not the quantity, which is this quantity, that maximizes revenue, that maximizes the area of this guy here. Okay. All right, so do I set it where marginal revenue is equal to average cost? No. Why? Because I set it, as I said, where marginal revenue, this line here, my board is messing up, where marginal revenue is equal to 0, where additional producing additional quantity will actually reduce my revenue. Okay, I'll still be getting higher prices, but I'll still be getting positive prices for additional units, but they make the triangle smaller because I have to keep reducing the price. So it's not average cost, because average cost will be positive, it won't be 0. Is it price? Is it where marginal revenue is equal to price? Well, actually, marginal revenue is never equal to price if you have a downward sloping demand curve. Yes, it's 0, as we said. Is it marginal revenue is as high as possible? No. Look, marginal revenue is as high as possible for the first unit, right? But if I want to maximize something, and suppose I want to maximize the amount of money I earn in a day, and I'm most productive in the first hour of the day, and then less productive and less productive and less productive and less productive. Okay, I'll stop when I become negatively productive. I don't stop at my peak, which is 9 a.m. in the morning. So E is also incorrect. Okay, just checking the thing again. I'm getting there. All right, it's been nearly an hour. Yikes. Okay, question 7. If the firm is a price taker, then the marginal revenue of the firm is what? Price taker. All right, this should be a quick one. Price taker. Okay. The firm is a price taker. Okay, so this was basically the condition. This plus free entry and exit of firms was what we called perfect competition. Okay, so the firm that's a price taker is such a small player that it's as if, or we assume, the amount they supply has no impact on the market's price, which is derived by the aggregation of all of the suppliers and all of the demanders. But their role on this is negligible, and we just assume it's 0. So there's going to be some price that's going to rise in equilibrium, setting the total market supply and the total market demand equal. I don't know why I drew that line there, just P star. Yeah, okay, P star. This is market demand, this is market supply, this is the quantity total exchange in the market, and this is P star, so this is the P star that the firm is effectively facing. Okay, the amount it supplies has no effect on this P star, and in fact, the amount it's supplying is so small relative to the market as a whole, we just assume it can supply, this is big Q, I believe, it can sell as many units it wants to produce at this price, P star, so P with 1 star. Okay, so what is its marginal revenue? Marginal revenue. What was marginal revenue? Well, revenue is price times quantity. Marginal revenue is if I increase quantity by 1. So, total revenue is price times quantity. Marginal revenue is if I increase quantity by 1 or by a unit, a very, very small amount, then what happens to my total revenue? Right? Well, what is the what is the firm here, the price-taking firm getting? Well, this price-taking firm's total revenue is just equal to P star times the quantity it provides. So if it provides one more unit of quantity, it gets P star more units of revenue. Okay, so suppose price is 2. If it sells 1 unit, its total revenue is 1 times 2. If it sells 2 units, its total revenue is 2 times 2, or 4. So its marginal revenue was 2, basically. Okay, so in other words, the derivative of this with respect to Q. Marginal revenue for a price-taking firm, unlike for the price-setting firm we just saw in the last question, marginal revenue for the price-taking firm is just P star. Okay, i.e. the market price. All right, so let's go through our answer roll again. A somehow came out blank, so that is a very strange answer. B, equal to market price, tick. C, less than market price, no. D, greater than market price, no. Obviously, they can't both be equal to and less than. And E, a multiple of the market price that may be either greater than or less than 1. No, it's always equal to 1 times the market price. Okay. Question 8. If the firm is a price taker under perfect competition, charging the prevailing market price, if it lowers its price, what's going to happen? All right, so we're still dealing with these price taker guys. All right, I said you could sell as much as you wanted at price P star. Okay, if you were trying to go above P star, the consumers will say, we can get this same. Remember, one of the things about perfect competition is all the goods are identical. All the sellers produce an identical good. We can get the same good anywhere else at price P star. Why should I pay more than P star? So then they'll sell no units, okay? But that's not what the question is asking. The question says, if it lowers its price, what's going to happen? All right, so A, will it sell no units? Well, the consumer's going from table to table, buying units, whatever, or maybe there's someone collecting all the units. Doesn't matter. The idea is that if such a consumer found a firm that was willing to sell at price less than P star, I wouldn't have any problem with that. But the firm can already sell whatever it produces at price P star, okay? So it's not that it sells no units, it'll still sell whatever it produces. Consumer or the market maker will be happy to take advantage of this not very smart firm. B, sell twice as many units? No, I can already sell as much as I want, okay? In fact, I'll sell whatever you're going to choose where price equals marginal cost. You'll choose some quantity, or perhaps it goes around like this. But here at this intersection, average costs are above marginal cost. So this is the marginal cost of the firm. Okay, so it's going to choose this quantity, and it can always sell everything it's brought to market at the market price. So not twice as many units. If it wanted to sell twice as many units, it could, but that would have nothing to do with it lowering its price below the prevailing market price. It would have to just produce twice as much of the good, which it doesn't, if it's optimizing, it wouldn't want to do. C, increase its profit.